Welcome to Maths Tuition Hub. This is the part 1 of the GCSE Grade 9 question series. We will be releasing other parts soon. Please do subscribe to get more updates. Let's begin our questions now. In this question, OXYZ is a parallelogram. The opposite sides of the parallelogram are equal and parallel. The scalar quantities are also equal. OX is A, OY is B, and P is a point on OX, and P is dividing OP and PX into 1 to 2 ratio. So OP is a third of A and PX is 2/3 of A. And R is the point on OY, and R is dividing OY in the ratio of 1 to 3. So OR is a quarter of B and RY is 3/4 of B. And we need to work out ZP to ZR ratio. So write the equations for both of them, ZP and ZR. So Z to P is equal to ZO plus OP. That's the first one in the ratio ZP, and the second one in the ratio is ZR. So the equation for ZR is ZO to OR. So we don't have ZO, we have OP and OR in the diagram. So we are going to find ZO, and ZO is parallel to YX. They are parallel sides of the parallelogram. So if you find YX, and that is also equal to ZO. So let's find YX first. YX is YO plus OX, and YO is in the opposite direction of OY, so that is minus B, and OX is A, so YX is A minus B. And same ZO is same as YX, so which is A minus B. Now find ZP using ZO and OP quantities. So ZO is A minus B, and add OP is third of A. If we simplify A terms, we get 4/3 of A minus B. So ZP is 4/3 of A minus B. And now we are going to find ZR using ZO and OR quantities. So ZO is A minus B, and plus OR is quarter of B, and simplify both B terms now. So it is A minus 3/4 of B. So ZR is A minus 3/4 of B. We found both of them, so we will put them in the ratio format now. ZP to ZR ratio. So ZP is 4/3 of A, maybe 4/3 of A minus B, to ZR is A minus 3/4 of B. So to simplify this ratio, we need to make scalar quantities similar. That's why we take the first one as it is, but the second one we have to take 3/4 as a common factor, and that will give us 4/3 of A minus B. So now cancel 4/3 of A minus B both sides. The ratio will become 1 to 3/4, and it is simplified to 4 to 3. So the ratio of ZP to ZR is 4 to 3, which is our final answer. In this question we have sector and the cone. The cone is formed by joining OA and OB of the sector. We have the volume of the cone is 56.8 and the height of the cone is 3.6 centimeters. And let's label the radius of the cone R and the slant height is L. And let's take the volume of the cone, which is 1/3 pi r square h. So the volume is 56.8, which is equal to 1/3 of pi r square, and h is 3.6. So we are finding radius from this equation. So let's rearrange it to r square first. 3 times 56.8 over pi times 3.6, and then to r now, square root the whole thing. 3 times 56.8 over pi times 3.6. Let's feed this one in the calculator. R will be 3.88 centimeters rounded to 2 decimal places. Now let's find slant height as well. So L, H and R, they are in the right angle triangle. So we have to use Pythagoras to find L, slant height of the cone. So L is the hypotenuse, so L is equal to square root of r square plus h square. We have both values for r and h, so let's substitute those ones. 3.88 whole square plus 3.6 square. So enter this one in the calculator. So that slant height will be 5.3 centimeters rounded to 1 decimal place. Let's label that one in the cone. And now we have R and L, so we are going to find curved surface area of the cone, which is pi RL, and substitute both R value and then L value. Pi times 3.88 times 5.3. So enter this in the calculator. Curved surface area will be 64.6 centimeters square. This curved surface area is same as the sector area. So sector's area is also 64.6 centimeters square. So area of the sector is 64 point. That is area of the sector, not area of the cone. So now we are going to find angle AOB of a sector. So label that one. And OA is the radius of the sector now, 5.3 centimeters. So write down the formula for area of the sector. Theta over 360. Theta is our angle times pi r square. Theta over 360 times pi r square, which is equal to 64.6 centimeters square. So R is 5.3. R is the radius of the sector now, so which is 5.3 square, which is equal to 64.6. And rearrange the whole thing to angle theta. Theta is equal to 64.6 times 360 over pi times 5.3 square. Enter this in the calculator. And we also, if you look at the rounding restriction in the question, answer correct to 3 significant figures. So the theta value will be rounded to 264 degrees to three significant figures. So the angle AOB is 264 degrees. The next question is about simplifying algebraic fraction. So we take one by one. The numerator 7x minus 14. So factorize that one. 7 is a common factor and x minus 2 inside the brackets. The denominator x square plus 4x minus 12. So this is a quadratic equation. We have to do quadratic factorization. Factors of minus 12 add to 4. So 6 times 2, that will give you 6 times minus 2, and 6 add minus 2 will give us 4. So the factors are x plus 6 and x plus 6 and then x minus 2. And we can't do anything with x minus 6, leave that one for now and take another denominator x cubed minus 36x, and x is the common factor in both terms, so if you take that one out we got x square minus 36, which is x square minus 6 square, so difference of two squares, so the factors will be x plus 6 and x minus 6 for that. So let's put them everything in order now. 7x minus 14 over x square plus 4x minus 12 divided by x minus 6 over x cube minus 36x. So there's a division in between, so we have to write the first fraction and let's change the division into times and flip the second fraction over. So which is x cube minus 36x over x minus 6. So let's write the respective factors now. So first one is 7 times x minus 2 over x plus 6 x minus 2 times x plus 6 x minus 6 and over x minus 6. So if you find similar factors we have to cross them over. Okay, so only the remaining term is 7x here, so which is answer, which is in the form of ax. The next question is about bearings. So we need to work out the bearing of Charlton from Octon here. So join A and C. So the bearing is bearing of C from A. So from the north of A until you reach the line C, that is a complete bearing. But in this question we have some part of an angle outside the triangle 37 degrees, and then let's take the angle inside the triangle as x. So the whole bearing will be 37 degrees plus x. 037 because we need to represent bearing in 3-digit format. And now angle at B. To find angle at B we have two north lines on either side. North lines are parallel lines and there is another line AB passing through them. So angle 37 is co-interior angle at with angle B. So co-interior angles are at 180 degrees. So 180 minus 37, which is 143 degrees. That is the angle at B. And now find the angle inside the triangle at that point. So angle around the point is 360 degrees. So add both 143 and 150 and take away from 360. We will get angle inside the triangle, which is 67 degrees. Now to find the value of x inside the triangle, we need to work out the length AC. So draw the triangle ABC now. And label the available lengths and angles here. And now let's find length AC first. To find AC, we have other two lengths, and then we have the angle opposite to AC, so we can use cosine rule here. Let's label these with ABCs to write the formula. So we are going to find A. So A square equals B square plus C square minus 2BC cos A. So cos A is opposite to the length of AC. So substitute all the other values. B square is 8 square plus C square is 9 square minus 2 times 8 times 9 and cos 67. So enter this one in the calculator to get the A square value first. A square is 88.73 to 2 decimals, and then we square root the whole thing, full calculator display, and then we will get A value, and A is 9.42 centimeters. Sorry, it's in kilometers because other lengths are in kilometers as well. So length AC is 9.42 kilometers. Now let's find angle X inside the triangle. Let's draw it again and label the required lengths and angles again. The angle at B is 67 degrees, angle at A is X. AC is 9.42 kilometers and BC is 9 kilometers. Now we are going to use sine rule to find the value of X, angle X. So sine rule is A over sine A, B over sine B. So the B value is 9.42. Over sine 67 is equal to not x 9 over sine x, and rearrange the whole thing to sine x. Sine x is equal to 9 times sine 67 over 9.42. We need to find the angle here, x value. So x is equal to sine inverse of the whole thing. Now enter the whole thing in the calculator. So first press the shift and sign button to get sine inverse, and then enter the fraction inside the sine inverse. So x value will be 61.6 degrees rounded to the 2 decimal places. Now we are going to find the bearing. We got the x value. Bearing is 0.337 plus x. So 0.37 plus 60, 0.61.6. Because this is bearing, we need to take 3 digits. So if you add both of them, we'll get 0.97, 0.98.6 degrees. So that's the answer. The next question is about the equation of a circle and the tangent. OA is radius of the circle and line passing through A is a tangent of a circle. Angle between the tangent and the radius is always 90 degrees. So represent OA as R, and if we take OAB triangle, right angle triangle, angle at A is 90 degrees. OA is R radius and angle at B is 30 degrees. So we need to work out radius from this. So this is right angle triangle with an angle and with missing side. We can use circuit over here. So sine ratio, because OB is 16, because O is the point center of the circle and B is another point on the axis, x-axis is 16 and 0. So B is 16. So if you use the sine ratio here, R is opposite side and 16 is hypotenuse. So sine 30 is R over 16. If you rearrange this one to R equals 16 times sine 30, which is 8. R value is 8. So radius is 8. Now write down the equation of the circle. Equation of a circle with the center 0, 0 is x square plus y square equals r square. So center is 0, 0 here and the radius is 8. The equation will become x square plus y square equal to 8 square. X square plus y square is 64. And now take the value of P, coordinates of P. P is 3P and P. So substitute these coordinates as x and y values in the equation of the circle, because the point P lies on the circle. So we substitute coordinates of P in the circle equation. 3P whole square plus P square equals 64. 3P whole square is 9P square and P square equals 64. So 10P square is 64 and P square is 64 divided by 10, which is 6.4, and P will be square root of 6.4. So the P will be 2.5 to 1 decimal place. I'll be releasing more videos like this with GCSE Maths higher grade questions. Please subscribe to Maths Tuition Hub to get more updates from my channel. Thank you.